Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the fourth part. In this part, we're supposed to determine the standard equation of an ellipse, and we're supposed to sketch the graph of that ellipse given the coordinates of the two vertices and the coordinates of the two co-vertices. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the a will be under the x. Now, we also remember that the value for a is always greater than b. And the equation that relates a, b, and c is c squared equals a squared minus b squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is h comma k plus minus c. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, so we go over the problem here. We are given the coordinates of the two vertices. So we're going to sketch the dots for these two. So that's going to be on 4, 8. So it's going to go all the way up here. So this is 4, 8. This is our first vertex. And the other vertex is at 4, negative 10. So that's going to be on 4 and then negative 10. So it's all the way down here. So this is the other vertex. So these are the two vertices. We also have the co-vertices, which is on negative 1, 1. So negative 1 and negative 1 will be somewhere around here. So this is our first co-vertex, and the other co-vertex is on 9 and negative 1. So this is the other co-vertex. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So we're going to determine the middle point between these two vertices, or the middle point between these two co-vertices. We can go ahead and say that our center is actually located here. So this is actually the center between these two vertices and the center between these two co-vertices. So we can go ahead and say that the coordinate of the center is on 4, negative 1. And since the two vertices are vertical relative to each other, we can go ahead and say that this is an example of a vertical ellipse. So I'm going to go ahead and write that information up here. Okay, since this is a vertical ellipse, the general formula for vertical ellipse is x minus h over b squared plus y minus k squared over a squared equals 1. We remember that this center here is our h and k. So looking at this, we can go ahead and determine the values for a and b. Remember that the value for a, or the a squared, our a is actually the distance from the center to the vertex. So counting this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our a is plus minus 9. That means we go up 9 and we go down 9. This tells us that our a squared then is equal to 81. Now we can also determine the value for b, so we can complete this equation right here. Our b is the distance from the center to the co-vertex either way. So counting it, 1, 2, 3, 4, 5. So that's going to be plus minus 5. This tells us that our b squared is 25. Now we are going to plug this a squared and b squared into this equation. So we have x. Remember, this is switch and switch. So that would be x. Since that is a positive 4, so this will be a negative 4 squared. And that is over our b squared is 25. So I'm going to write that down here. 25 plus, that would be y. Our k is negative 1 switch. So that would be a y plus 1 squared over our a squared is 81. So I put 81 right here, and that is equal to 1. So this is the equation for this problem that we have up there. Now we can go ahead and sketch the ellipse. Okay, now we are supposed to locate the two foci. Now we remember that the distance from the center to the focus is c. And so we can go ahead and solve for c using the equation c squared equals a squared minus b squared. So I'm going to go ahead and write that up here. Since our a squared is 81, so I plug it in, 81 minus b squared is 25. This tells us that our c squared is 81 minus 25 is 56. So we're going to square root both sides to solve for c. So our c is actually plus minus square root of 56. Or this is actually equal to plus minus square root of 4 times 14. This tells us that the c is plus minus 2 square root of 14, or this is approximately 7.48. This tells us that we go up 7.48 and go down 7.48. That's the location of the two foci. Okay, so then we can go ahead and say that the coordinate of the two foci would be, we remember that since this is a vertical ellipse, the coordinate of the two foci would be h, comma, k plus c and h, comma, k minus c. So it's pretty much we use this h and k value, so that would be h is, that's going to be 4, and then our k is -1, but then we are going to add this c. So that's going to be plus 2 square root of 14. And the other coordinate of the focus would be 4. And then that's going to be -1. This time around, we minus this c. So minus 2 square root of 14. So again, please notice that it's exactly the same as the coordinate of the center, or hk, but we're just adding the c to the k. So that is 4, -1, and we add the c, and then that's 4, -1, we minus the c. And so we can go ahead and determine as well the length of the major axis and the length of the minor axis. So this is the equation for this problem right here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we are going to plot these 4 points right here that represents the coordinates of the vertices and the coordinates of the co-vertices. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. We can tell that the center for this ellipse is located down here, because this is the midpoint between the two vertices and the midpoint between the two co-vertices. I'm going to label this as letter C. And so we can go ahead and say that our center is located at -5, -6. And since the two vertices are horizontal with respect to each other, we can go ahead and say that this is an example of a horizontal ellipse. And I'm going to write that information up here. Okay, I also wrote here the general formula for a horizontal ellipse. Now, please notice that our a squared is under the x because we have a horizontal ellipse. Now, looking at this problem, we go ahead and say that our a is the distance from the center to the vertex. So looking at this, the distance is 1, 2, 3, 4, 5. So our A is 5, and our B is the distance from the center to the co-vertex, and that would be 1, 2, 3, 4. So our B is 4. So I'm going to write that information up here. Okay, now we are going to plug these values A and B into this and the center HK. So the equation would come out, that would be X switch, so that's plus 5 squared over A squared is 25 plus Y switch, that's a plus 6 squared over B squared is 16 equals 1. So this is the equation of this problem that we have up there. Okay, now we are supposed to determine the location of the two foci. Remember that the location of the foci is c distance from the center. And we are going to use the equation c squared equals a squared minus b squared to solve for c. And I'm going to show the work down here. This tells us that our focus is located 3 units left and 3 units right. So that's 1, 2, 3. So this is our first focus, and 1, 2, 3. This is our second focus. Now, the coordinates of the two foci would be, and I'm going to show the length of the major axis and the length of the minor axis up here. So this is the equation for this problem that we have right here, and this is the graph for this equation. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!